Okay, welcome aboard everyone and welcome back to today's our planning session. So it's what we're calling sort of the planning in the sense that we're going to do the first 2 months, unpack what they could look like. I'm going to try and give you as many ideas and maybe what the focus could be for those first 2 months. If you're following sort of the year at a glance, the way we set it out, that will allow for bridging to happen. It will allow you to take your time in going through. You're not going to get through all your outcomes as stated in September. That's just not going to happen, nor should it. So we're going to give ourselves permission to go slow up front, and then we can speed up later once the students have revisited, are caught up with the bridging, and that might not happen till February. So when I say don't panic, you're not doing everything right up front. I really am sincere about that. So we're going to look at those first 2 months. We're going to look at kind of what grade 5 looks like. Grade 5 has some shifts to it for sure. It got some materials from literally from grade 6 and grade 7 that got shifted into it. So it would not be realistic for us to assume that we're just going to leap into an outcome that's stated and just start working on it with the students. So we're going to start deliberately slow. I've got a couple of things on the screen here that I can point out to you right off the bat. We're going to start looking at things like plotting points, looking at things like transformations, which they've been doing for quite a while. So we want to review that. Right up front, we're going to do some work on that because we're also going to slide in a small unit from grade 9 right into that grade 5 curriculum. All doable, all very manageable. It's just that we need to have the background to do it before we can start. We're going to work on math facts because we know that they didn't come out of the new grade 4 program mastering 12 by 12. So we need to work on that for sure. And we need those skills anyway when we're talking about multiplication of numbers. So again, starting small, no big assumptions. Anything that you get that's a bonus where they say we got this and they're all doing it well, consider it a bonus and just move on. But in the meantime, we'll just be deliberate and we'll look at what we're listening for and looking for to make sure that we know how fast we can go. And we're going to talk about money. Money will be one of those pieces again that we're going to use as a manipulative, not just as the financial literacy side of it, but as the tool to double check for addition, for multiplication, to check for whether or not they know any of the values for dollars and cents, because dollars and cents will help us as we move into the world of decimals, right? So we're not going to start with that right off the bat, for sure not. Okay, so let's get going. We're going to begin with our land acknowledgement. We respectfully acknowledge that we are situated on traditional lands across the province of Alberta, home to many First Nations, including the Cree, Blackfoot, Métis, Nakota Sioux, Saulteaux, Inuit, and many others whose histories, languages, and cultures continue to influence our vibrant community. And at the bottom right there, I know it's white, but you see I've got a link in there, and that link is if you are looking for some topics that are indigenizing the, looking at math through the Indigenous lens, that link there will give you several opportunities to see how you can embed that into your math program. And it's more really for division 2, 3 and up, not so much for primary. They're not just talking in theory about what could be done. They actually give you sample lesson plans and their specific topics. So you need to kind of pair them to our outcomes as you go through. So you might find that helpful as you go through. So if we were doing this live, for those in High Prairie, I'll be coming up that way in June, and we will do some of these live because some of this stuff is really better hands-on. But if we weren't, one of the questions I would ask you right now is just to think about, new curriculum or not, how do you start your year at the beginning of the year with math? Like, what's your usual routine? How do you get to know the kids, new kids that come to your school? If you have feeder schools and you're the receiving school, how is it that you go about finding out about your kids? And really just having the time to even talk with your shoulder partner about that at some point. We don't do it today, but the reason I ask that is because that's not going to change. You may be faced with a new curriculum, but that doesn't change what I need to know about my kids. In fact, it just emphasizes I really need to know what they know so that I can move forward and bridge more efficiently. So I need to take the time to listen, hear, see, be deliberate in my actions, in the activities, lots of activities that I can give them but through those activities, what am I gaining as far as knowledge of their background knowledge? Where are some holes and gaps? Hey, where are the places where I thought I'm going to have to start from scratch? And I don't, because they already know it, right? So that question that comes up front there is purposeful and reasonable. So this is not an unusual slide or not one that you haven't seen before. We showed this to you when we did the unpacking of the curriculum. We went through the key documents. But the reason I want to bring this back again is it really kind of speaks to the fact that the grade 4s live in a little bit of both worlds. They don't just live in Div 2. They live in Div 1 as well still, because some of those key big rocks that lived in grade 3 have to get redone or reinforced in grade 4 to make your world in grade 5 a whole lot simpler. Now, they're not necessarily going to have all of those skills, even though they've done that in grade 3 this year. They may not have gotten to the depth that they needed to, especially in unit fractions. That's a huge, huge one. And so if we haven't, we would hope that the grade 4 teachers are going to just start from scratch. Assume that they haven't done unit fractions. They will have, but we just start with they haven't and work our way through and see where they're at. Because those unit fractions, students need to understand the foundation of it beyond just a circle with 7 different pieces in it. And where I say, if you colored one of them yellow, what have you colored? 1 out of 7. That's correct, but that doesn't mean I understand what a unit fraction is. Would they be able to count on a number line by that unit fraction, right? Students need to have good understanding of unit fractions, just like they count on a number line with 1, 2, 3, 4, 5, 6, 7. That's the fluidity that we want with those unit fractions. Because as you start getting into fractions, and in particular improper fractions, I need students to really understand, how did I get to that improper fraction? Don't just teach me the rule and the algorithm of how to change an improper fraction. Teach me how I got there. And then I'll probably figure out the rule by myself on how I'm going to change the format of it. So the grade 5s will be really looking to have grade 4s arrive at their doorstep with that background knowledge. Now we know they didn't do the new grade 4 last year, so we're going to assume the same thing. Let's just assume we need to start with some unit fractions right up front. We're going to go slow. We will not run out of time. We will be fine. We just need to give ourselves permission to go back and make sure that they've got those foundational pieces before we want to try zipping into our outcomes and just saying, okay, I got to move on, whether you've got it or not. We've got time. We don't have to race. And for both the 5s and 6s, you're very closely aligned with some of the things that are going to happen. A lot of the things from 6 will happen in grade 5. So again, talking to your grade partner from grade 6 would be helpful if you haven't already done so, because both of you have some junior high links that are going to happen in there. So we want to make sure that you're clear and that you're moving forward in sort of purposeful moments. So we're going to talk about what happens in September and October. What portions of outcomes will I just start on? So I'm just going to take snippets from here, because I'm going to revisit them anyway. And then we're going to look at some of the key concepts that live in your cusp so that we're all clear that we're all teaching the same thing. It doesn't matter whether I'm up north or down south. I need to make sure that we're all finding the same concepts and that we are understanding what parts we need to assess and what are just sort of one-offs. Those are going to be important. Taking an inventory will be that part about how could I do this? Where could I start? What are some activities that I can do? So if there was anybody that was here from grade 4 yesterday, you're going to hear some things that we did last day happening again, because same bridging, right? I still have to get the same foundational pieces going this coming year. It'll be very similar in some starting points for grade 6. There are definitely some differences. So just as a quick review, organizing ideas where your big rocks are. So when we say is Alberta going to give us the essential learner outcomes? No, you already have them. They live in the organizing idea. We just need to make sure we can find them. It gives us that broad concept that goes across a bunch of grades, right? It's not just about my grade and what I'm going to teach. The guiding question is a question for you, the teacher, not to be retooled into an I can statement on the board. It wasn't about the kids. This is about you reading the question, answering the question in your mind, and how you're answering it would probably impact how you're going to plan for your learner outcome, right? That was the intent of it. They're linked very tightly to our learner outcomes. which are the piece that we know. Learner outcomes are what we need to report on. It's what the kids have to demonstrate they know how to do and that they conceptually understand. And once I've done all the understandings in my CUSP and I've done a really deep dive into those understandings, if I can say that I have seen the students consistently handle those understandings, then I can confidently say they're probably ready to do an assessment of the learner outcome. Those understanding columns are the key kingpins of everything that we do in those CUSP. That's the most important column of all of them. Okay, the knowledge, understanding, skills, and procedures are those CUSPs. It has 3 columns. One is a factual piece. One is also a factual piece when it comes to skill. And then the middle one is the deep dive. Have I actually taken students to a higher level of thinking in order to use the factual knowledge and skills that I've taught them to say that they can do this in an unknowing situation, one that I didn't give them as an example on the board, one that I didn't show them in a book, that I didn't put on a piece of paper. Here's a new scenario, and they can use the tools that they've learned to find their way through. That's the key. If all we do is just give them different words with different names and a different animal in an example that we used on the board in an exam question, we've done nothing but stay at surface level. Because if I'm a good memorizer, I've memorized your format of your examples. I know exactly what to do. That doesn't mean I understand the math. It means I've memorized the algorithm well, and I'm going to get 100% on it, but that doesn't mean I know it. And that's a really key difference between the two. And then the last pieces, our competencies, remember, come from the 2013 ministerial order. They did not change. We still have them in vogue. Every teacher, every year, every subject, every child. So every child would meet from every teacher in every subject, a review of the 8 competencies embedded in some assignments or project that you're giving me to work through. So I, as a student, learn what my strengths and weaknesses are in those areas and can articulate where my strengths are and where my weaknesses are. So the numbered outcomes document is kind of a key piece. We should have those already from our last session. And just a reminder that the numbered outcomes document is identical in order to the one that's on the new Learn Alberta site. We did not change anything other than to number them to make it easier to reference if you're working with a grade partner, doing it by Zoom. It's just easier for us to find where we are in the document. Nothing else is different. Basically, that's all we're looking for. So the organizing ideas that we find in our numbered outcomes document are reflected here, but we don't see them starting in every grade. We see that some of them finish in grade 4, some of them start in grade 5. So in this case, coordinate geometry, for example, is starting in your grade, and not a huge piece, not a big leap for us to be able to do with the students. In fact, one of the easy pieces that we started with the pilot groups. So this is kind of our starting point today that we'll talk about. But you'll see that some of these clearly go through all of our grades. And they're kind of the big rocks of our math program. Quick reminders that when you're reading the numbered outcomes document, make sure that you look at some of the wording that appears in those columns, especially in the CUSPs, that if I see the word include or including, anything that comes behind that. So you see here, including, comparing to quantities, taking away, yada, yada, yada. Anything that comes below the including must be part of your lesson. Not all in the same day necessarily, but you don't get to say, I only do the first 2, I've never done the last one, not going to do it. That's not an option. They're saying anything that's in there, in including, must be taught. That does not say that that's the only thing that I have to teach. And a lot of times teachers said, oh, I've done this, I do this, and the kids have always done really well with that. And by all means, you want to keep those practices. So you're not throwing away good practice. You can add, you just can't delete from that list of including. As opposed to such as, or for example, depending on which documents you read. If you look in the science document now, it's for example, for example. So treat for example and such as the same way. Whatever comes below that or behind that, you have total discretion over what you want to use. If you want to take all the bullets that are there, use them. If you only want one, that's fine. If you don't want any because you have better ones, all good. You pick whatever gets the outcome covered and that you're comfortable with, and maybe in your particular area that you live, you need to have a different kind of example, knock yourself out. You have full choice on that. There's not a problem. And then the last one, not so much in grade 5 and 6 anymore, but you may encounter some words that are in brackets. And if they are in brackets, those are the correct mathematical terms, but they're suggesting that it might be too difficult for the student to handle that term. So they intend them to be for the teacher or the parent if they're homeschooling, and we would use the word that's in front. Now, clearly, by the time we get to grade 8, we would want that, or grade 5, sorry, we would want them to know these terms, and you won't see them in brackets in grade 5. This is a grade 2 example, but even the grade 2 teachers have said, I would still show them those words. I would still articulate the words. I just wouldn't assess them, maybe using that on an assessment, but I definitely would make sure that they know them and start with them, but I probably would use slide turns and flips the most. And then the last piece would be that skill column. We have skills and processes. That's not the only place that you find the verbs, but it's the majority of the verbs sit there. And in that particular concept, or in that area, what we're seeing is I have a process that I need to be able to articulate. I need to be able to demonstrate to you that I know that verb. I know what it means. I know how to use it in different contexts. But that's the other piece, that for us as teachers, we need to watch how those verbs are placed in a context, because they do have a definition of what the verb means, but it could be tweaked depending on the context I'm in. So sometimes when the word is used or the verb is used in a particular paragraph in our documentation, it actually implies that it could be any one of the words that you're saying below. So for example, here you see interpret compositions and quantities to 10, which could be that interpret means they could identify, like, can they subbatize 10 or 8 or 7? Can they make 8 or 7, right? So there's different ways that I can interpret that verb itself in the context that it's given. And do I have to use just that verb? The answer would be no. If you feel that one of those verbs that we're kind of saying here, or you're in your mind saying, isn't this the same as identifying? If that is what the kind of process is that you're going to have them do, then use that verb by all means. You're going to find that there are certain ones that we use more of in math than we do with others. Same thing here. I see it in geometry. I see a grade 3 one, but again, it's interpret with a different context. And now I'm seeing that that could imply, again, a whole new set of verbs. So be flexible with that and know that those can change. The year at a glance, this is our document that basically tells us, or sorry, not the year at a glance, the curriculum comparison tells us, what did we teach in the old side? What's our old curriculum? And is there anything in the old curriculum that partners with the new? So that was the purpose of that document. If you did not get those documents, I will show you where to find them at the end of the session, just to make sure that you all have access to them. And then the last one is the year at a glance. And this is the one in which we've kind of taken the curriculum as is, understanding that we need to bridge. And how do I bridge to get from September 1 to June 30th and meet all my new grade 5 outcomes? So slow at the beginning, deliberate, be intentional, and then we work our way as we go forward. So we will use the year at a glance as our PD framework so that we know that we're all working towards the same thing. But you as a teacher don't have to use that. You can start anywhere you want. If you prefer to start someplace else, feel free to do that. You can just come to the PD sessions and glean whatever we have there for resources and use them whenever you're ready. The only way that you might find the year at a glance helpful is the yellow pieces are sort of the bridging starting points. So if you're starting at a different place, you might want to find it in the year at a glance and have a look and see what was maybe suggested and what the pilot teachers were doing when they were doing some of that bridging. What were some starting points that they did, and what were some areas that they focused on? So it looks like this in a larger version. So we have, and we don't necessarily see the outcomes in order, and we don't see every one of them going 1, 2, 3, 4. There was never any intent from Alberta Education for you to pick up the curriculum document from New Learn Alberta, download it, and teach it in the order that it appears. That was never, ever an intent, and it wasn't designed that way. So we have to be intentional about picking what fits together, especially when we're bridging. We have to be very careful that we're not just launching into an outcome just right away because it's the next one on the list. where in fact they don't have background for that one yet. So this is where we're being a little more intentional about what we put together. So you'll see that we see 5N1, in other words, grade 5 number, first outcome. I see 5N2, I see 5N4, and you'll see that it's exactly the same for September, October. There's no leaps happening there. We're just hunkering down to find out where the kids are at. We're going to tool it up a little bit at a time if my kids are ready, and if they're not, just put on the brakes. We got the time. And then by the time we get to November, we still have those three there, but we're also introducing 5N3. So again, by introducing, that's what I'm saying deliberately. We're introducing, we're not necessarily finishing by November. We also see in September that we have some things in geometry that we started to do with the students right off the bat. And we also started to work on coordinate geometry in October. And this is a really good marriage of these two topics in grade 5, because it gives me as a teacher time to find out what they know from grades 2, 3, and 4. But while I'm finding out what they know, I'm still going to teach them some of my new outcomes. So this is one of those rare exceptions where we were able to launch in to the new outcome, pick up stuff from the background as we go through, and still move forward even into coordinate geometry all at the same time. So we'll unpack that for you a little bit as well. And then we also introduced algebra sort of into sort of end of September, beginning of October. And we were focused more on just basic order of operations, math facts, 12 by 12. And we're going to do 12 by 12 work all year. Like it's not just about October. But this is where we became a little bit more deliberate. We actually don't start on anything algebraic expressions. All we're starting with is just, do they know that, you know, addition comes after multiplication? So if I went 2 times 4 plus 3, do they know that that's how I'm going to do it, is multiplication comes before addition? Simple, simple. And then if they're good with that, then let's throw a bracket around 1 and see if they know that the bracket needs to be done first, right? So just baby steps, because by the time they get to grade 6, you're doing the full-blown grade 8 exponents, the whole shebang. So you too in grade 5 have gone quite a bit further in the order of operations. Not all in September and October. There is no rush for that. So we're also including a bit of a concept map. Some of the teachers that we were working with, especially in person, were saying, you know, we gave them cards and they're saying, this would be good if we even had on a map. This is a map. This is not the map. This could be done in multiple different ways. But what we want to show you is that we're starting small, and even in all the small starts, everything's connected for a reason. So we're starting with number, and we're going to work with number lines. We're going to work with counting, and we're going to work with math facts. All of those are sliding in together at the same time. But in working with number lines, we're actually going to tie that into our plotting of points on an XY axis. So I still have a number line. I can still see it starts at the origin 0, but now maybe my number line is going to go left, right, and up, down, right? So I'm going to create that quadrant 1. I'm tying some of those pieces already together, but I'm also taking money and putting it on a plain number line. And I'm saying, what unit fraction can we find? They would have done that in grade 3. Maybe they didn't do that in grade 3. So let's backtrack and make sure that they're good at that. So we're building all of these pieces together at the same time. And the students don't need to know that they're doing multiple outcomes. They just need to know we've got all these different activities that are happening at the same time. And you're just assessing to see where we're at. That's all we're really listening for and watching for. So we're going to do money. We're going to do the value of money. Do they know money? Don't assume because they're in grade 5 that they did money last year. Hopefully they did. If they didn't, start from scratch. Just assume they know nothing. Anything's a bonus. Do they know dollars and cents? Can they add dollars first? Don't worry about the cents. Just do dollars. Can they show you $24? Anyway, can they show you $24 in a base 10 system of money? Not just a bag of money with random stuff in it. That's one bag of money. Then there's another bag of money that we should have that's based on a base 10 system. And I'll show you what we put into those bags a little bit later in the slide deck. So I can be intentional now as a grade 5 teacher or a Div 2 teacher. I might say, just want to work on I want to work on base 10. So can they take 10 loonies, convert them to a $10 bill, $10 bills to $100 bills, hundreds to 1,000, right? That's your base 10 blocks. That's how they work. but let's not bring out base 10 blocks. Let's just deal with money so that they can do that work. Okay. So this is really what this is just showing you, is how we're going to connect all of our different pieces, and that we're going to take the number lines and work with it in coordinate geometry at the same time. You're doing quadrant 1 in grade 5. Grade 6s are doing quadrants 4 of them. Okay, they're doing the Cartesian plane. So a little bit of a shift there for sure. Okay, so let's have a look. In September, we're looking at 5N1, which is really saying students analyze patterns of place value. I'm not going to launch into bringing out column sheets and doing place value discussions. I don't care about that right now. I'm going to start very small and be very intentional. Want to remind you that the bullets that appear here are your understandings. This is not your knowledge, and it's not your skills and procedures. I still need to bring that document or have it sitting beside me while I'm working through all of this. So it says in here, place value extends infinitely to the left and to the right of the ones place. So they're assuming we're going to just jump right into decimals. And yes, they should have done decimals in grade 4, but maybe they didn't. And maybe they didn't understand it. So let's not go there right off the bat. Let's start with money. Let's just start with what happens when I have whole numbers. I'll get into cents after. Okay, we can bring dollars and cents in. If they're solid in money, then you can bring the dollars and cents conversation in. But dollars and cents, not as much as dollars and tenths and hundreds. Just use dollars and cents. That's all we want to talk about, because later we're going to ask them to do dollars and cents and tenths and hundreds, right? We want them to tell us that, not us tell them. So we're going to introduce basic money skills. We're going to look at that from this perspective of using a base 10 system. If they already know money, if they don't, just do money, do the basic money. We'll look at that in a minute. And we're going to put them on money on a number line, which will help me get to basic fractions. And when we talk about a basic fraction, unit fraction here, we are not interested in hearing the word numerator and denominator. We're interested in a unit fraction being 1 out of something, 1 out of something, 1 out of something. That's the good starting point, because sometimes when kids hear the word fraction, they freak and say, I can't do that. But if they didn't hear the word fraction, they actually can motor along pretty good. So let's just not go with that terminology right off the bat. We don't need it. We're going to focus on denominators of 10 and 100. That's the money. That'll be the dimes. That'll be the pennies on a number line. Can they even count by that on a number line? Can they see that it's 1 out of 10 dimes? Can they see that it's 1 out of 100 pennies? I'm not going to say hundredths, and I'm not going to say tenths. I'm just going to say 1 out of. Okay. So this is kind of our starting point that you're seeing in the yellow. We're working on those pieces, and then as you find out where they're at in September, if you're able to move forward, great. If you're not, stay with whole numbers. There is no rush to get to dollars and cents. Lots of time. Okay, we look at 5N2, students add and subtract within 1 million. Well, we're not going to worry about a million, not in September, not even going to worry about 100,000. You're going to worry about 100. Do they even know 100? Nailing 100. And some kids will say, I can do that in my head. Perfect. That's what we want to hear. So if we can do 100, can we do 200? If we can do 200, can we do 500? If we can do 500, can we do 1,000? Right? Increment them in small, manageable baby steps and make it very manageable so that even students who struggle in math will say, oh my gosh, this grade 5 math is so easy. They don't need to know their review. They don't even know when they have to get into the grade 5 stuff. Let's just transition them through activities as they move forward. Okay, so initially we said start from 100, work your way to 1,000. If you can't get to 1,000 because they're not there, then go to 500, go to what you can. But if they haven't mastered 100, don't go anywhere. Stay with that mastery of 100, because once they can do 100, then getting dollars and cents is easy. But if they don't even get 100 basic as a whole number, we're going to struggle getting to 200 and 500. It's going to be a fight all the way through. So just nail all the ins and outs of 100 and all the different ways that we talk about later. Students multiply and divide natural numbers within 100,000, including standard algorithms. Okay, I'm going to unpack all of these really specifically in the subsequent slides here. But really what that's going to say is I want to do some multiplying and dividing. Why don't I just find out if they even know any math facts? Do they even know 10 by 10 coming out into my new class? And if they don't know 10 by 10, let's start there. My goal at the end of 4 was 12 by 12. Well, maybe I'm not there yet either. Or maybe you've got kids that don't even know 5 by 5 yet, right? We need to find out where they're at. You're going to pull your hair out, as you already know, when they don't know their math facts. I need to know something if you want me to do some multiplication quickly. Otherwise, I'm going to be using a chart the whole time. And I must have some better strategies than just a chart. Remember, it's a no calculator curriculum. So it's right up front in your introductions, right in the documents, that this is a no calculator curriculum. So we need students to have some strategies that if I don't know my math facts, now what? You're not going to just hand them to me and say, go home and memorize them and come back tomorrow. I need a strategy that I can figure out a way to get the answer. We'll do some activities for that as well. Okay, so we're not even worried about all this other stuff. We're just starting with the yellow. That's really our focus. Okay, start small baby steps. The pilot teachers indicated, they said, can you just put in green math facts all the way across, just to remind us that we're going to use it as many times in a week as we can. We're not just going to say on Tuesdays, we're going to practice math facts. If they've got 5 minutes left over, let's teach them some games and strategies that they could use to practice their multiplication tables or division, whatever it is you want me to work on. So it's teachable moments at any time. So before I launch into all of those pieces to do, I need to make sure that I am looking and finding the same concepts that anybody else is finding in the province. I need to make sure that I'm looking and assessing the same things. Now, in the interest of time, I'm not going to play this video, but this video talks about what is a concept. And it's not about math. It's actually about science and ecosystems. So at the end of it, when we've done it face-to-face, some teachers have said, okay, I thought we were going to look at the math curriculum. So my first question is, how did what you just see when you watch this, how is what you are seeing related to math? They're all related. So how is what you're seeing related to math? How are you taking the example of unpacking an ecosystem to unpacking the math, especially when we have to bridge? It'll be the same linkages. We just don't stand up and deliver. We need to find out what they know and work from that level and expand their ability to see connections, hence cutting that map as well. So I'm going to skip that one for now. It's not a long one, but I still want to make sure that we have time here. So a concept, just as a quick reminder, or if you've never worked with them before and named them like this, you've known them, you've always done concepts, but maybe you haven't named them this way. It's something that's a noun. It could be 1 word, 2 words, maybe. It's not a sentence, not a paragraph, not a phrase, not a definition. So I'm looking for a noun, 1 or 2 words. I'm looking for something that's broad. It's timeless. It existed 100 years ago, exists 100 years from now. It's universal. I can go anywhere in the world and find that word, maybe not in English, but the meaning has meaning in their language as well. It's not about Alberta. It's not about North American teachers. It's about worldly words that we can find everywhere. And there's lots of them, for sure. The broader they are, the easier they are to transfer to new scenarios. They don't live in math. They live in every subject that we teach. So if I teach a concept that's really broad in math, I should be able to take that concept and apply it in science. The students should see it in science without us telling them. They should see it in language arts. They should see it in social studies, etc. Like it shouldn't live just in the minds of when I walk through the door in math class. Okay, that's what we're trying to get students to see, is that they're all connected. So here's an example, a chair. A chair is a concept. If I wanted a chair, I might go to the biggest, broadest concept, which is furniture store. I'm going to Leon's. I go to a furniture store. I walk in through the door. Somebody greets me and they say, what would you like? I say, I'd like a chair. Their next question is probably going to be, what kind of chair would you like? So the furniture store is like the umbrella. The chair could be all the rungs that are in there, because now I have to figure out what kind of chair am I looking for. So I might say I'm looking for something like a bar stool, which could be considered a chair, but it doesn't look anything like a living room chair for reading, doesn't look like my office chair, etc. So once he knows or she knows what I'm looking for, she can say, want you to go down that aisle there, everything to your right, that's what you're looking for. And everything else is put away. Whereas if you're teaching grade 6 and you walk through the door, you might say, I'm looking for a living room chair. Still looking for a chair, but they're going to unpack how to make a living room chair. Oh, you're going to take that aisle going down that way. So everything on their side, on their right, is out of their way. So this is how we kind of unpack concepts in the math curriculum. There's a broad thing that sits at the top. And if I take it as an inverted triangle, the broad base is at the top. And I start to get more specific as I get to my learner outcome and my cusps in my grade. That's where I find out what kind of chair I'm going to actually get. So we see in this diagram here that there are several of them that are linked together. They could be just general character. What kind of character? So I might be taught studying any one of those in any given year, all of them in 1 year, right? Or if I just go to the end in math, mathematics is a concept. It's pretty broad when I just say math what? What do you want me to teach in math, right? So then I look at different units that I could teach. So this is how we start to break down those super big, broad ones that sit up in the organizing idea. Remember, that's where these big rocks sit. We need to find those big rocks and be able to identify them. So if you have your numbered outcomes document, can you find 5 and 1? If you're going to bring it up on your screen, that's fine too. Or if you can read mine, I've got it up on the screen. We won't have time to do the whole thing, but what I'd like you to do, and you don't have to put it in the chat box, just on a piece of paper in front of you, or if you have it with you, I want you to go through and find the concepts that live in 5 and 1. So we're going to start right at the very top in the organizing idea. So we're starting with a number. And the very first word I see is quantity. Quantity is a concept. I would circle that word if I was doing it on paper. Measured, numbers. Okay, those are all concepts that live in there. If these were not ing, counting, labeling, if they would just count, label, then I could consider those as concepts. So because they are action verbs right now, that's a process. So we won't worry about those. So go to your guiding question, go to your learner outcome, and then just maybe grab the first sentence in each one of them, and just so that we find that we're at that same place, right? So find the concepts that live in each of those lines. I will share an answer key with you, but just to give you a minute to do that and just jot them down. Now, if I was doing this with a grade partner, if I have another grade 5 teacher in the school that I'm working with, we would do this individually. It takes a minute, doesn't take long. And then we would compare before we start planning. Let's make sure that we're both on the same page. If I don't have another grade 5 teacher as a partner in the school, I could work with a grade 4 teacher, grade 6 teacher. I mean, they're doing the same thing. So you can grab theirs, they can grab yours. You can quickly go through, say, these are the words I found. What did you find? And we go from there. So let me just go one slide further, and you can see here in the red what the concepts are. So you'll have a copy of the slide deck, so you don't have to copy them all down, not to worry. So one of the questions that was asked recently when we were doing in-person was, why do I care about this? Like, why do I even want to do this? Well, for one, it tells me that I know what the concepts are that I'm unpacking. But really what you should have also found was that I see the same words come up over and over and over again. I keep circling the same words. And that same word pattern you're seeing throughout here: numbers, decimals, numbers, position, decimal, numbers, value. It's pretty hard to miss that the big grounding in this 3 columns is that. If I want to go off on a tangent and teach something else, that's fine. But I might not assess it because that's not the rocks that live in this particular cusp. So it really helps to solidify what exactly should I be focused on here. I'm seeing it come up over and over and over again. So when we do this on slides, I'll do this each time we meet. I always have a slide that will look like this for each of the ones that we're going to do. What are some things that we can do with this? Like, how do I bridge into this? How do I address that yellow that's at the bottom? Those are just the screenshots from the year to glance. So where am I going to start? Well, I'm going to start with 100, right? 100's my focus. If we can ace 100 by addition, by subtraction, do they know 10 by 10 multiplication facts? If not, what do we know? Like 100 in every different way. Can they count to 100? Can they skip count by 2s, by 5s, by 10s, by 20s, by 50s? Like all those things that we used to do in upper grades or older grades, now happening in grade 2 and 3. So do they know all that? Can they use money to skip count to 100? Can they skip count by 20s? Can they, like all of that? I can learn money, but I'm using it to do the math at the same time. So mastery of 100, leave the decimals out. Don't worry about that. Can they show you $22? Can they add $54 to that? How much do I have? Put the tens together, put the loonies together, right? So can I quickly do that work? That's grade 2 work to do that, what I just said in the numbers of the money. So if grade 2s are doing that, are my grade 5s proficient in it? If not, they'll catch on quickly, but they still need to have that opportunity to show you what they know. Putting 2-digit whole numbers in dollar amounts. So calling it out, show me $35, show me $37, show me $55, whatever. If I'm doing it with a random bag of money, I can show you $55 any way I want. Whatever's in my bag that I can make $55, great. Once you've got past all of that, showing me any way I want, then I might want to just stay with base 10, because then I can get into that place value conversation a little bit sooner, and it makes a little more sense for the students. Count their bills. Can they do that? Can they count bills? Can they skip count with toonies? Can they skip count with nickels? Like use it for skip counting to 100. Master 100, can we go past 100? What else can I do? Can they use the $100 bills to get to 1,000, right? So what is our magic number? If 100 is solid, move forward. Can they then start to learn about dollars and cents, not tenths and hundreds, dollars and cents? How many cents make a loonie? 100. So can you show me $1.26? Can you show me $2.35, right? And so just getting them to show me those different amounts, because at some point then I might say, show me $2.35 above, and below that, show me $1.26 below. And what happens when you put your dollars together, and what happens when you put your cents together? How much do you have? And for every 100 cents that I count, I'm going to trade it for a new loonie. That's your first starting point with money, but also your first starting point with decimals without talking about tenths and hundreds and lining up a decimal. Cents go with cents, dollars go with dollars. So strengthen that understanding first so that we can get to the tenths and hundreds later on. Okay, can they describe a 2-digit number to you? Can they, if you write it on, can they write it down in words? If you wrote the words out of a 2-digit number on the board, could they write out the number? If you wrote out a 3-digit number and called it out, would they be able to write the right number down? If you called out a 4-digit number, can they do it? Can you show me a 4-digit number which will have a 0 somewhere in one of those placeholder positions, right? That's an important skill for them to know before we start talking about place value. Who even knows how to write $1,054? How many of them are going to write 1,000 and then 54 behind it? Lots, I guarantee you. How many are going to write 1,054? Oh, they're going to go a couple of extra zeros, maybe 1 0, not sure where the 0 goes, or they might put it at the end, right? So that's that not understanding how that number is put together. What strategies do your kids have coming into grade 5 for adding numbers, for writing numbers? How do they break down 1,054? If they were putting in an expanded form, how could they do that? That's all stuff pre-grade 5. But those are all strategies that if I'm a kid who sucks at math, I need a way to get there. So if I don't know some other strategies, this is a good time for you to find out what I know and maybe what I could use along the way. Okay, we did that one, regrouping with money. We'll use the mats, we'll look at that. We could roll dice. Roll two dice, 2 different colors, and just say, what's the biggest number? Like really fast games. These are kids, everybody can do this, right? Not somebody who still struggles with math can get into this. So roll your 2 dice, what's the biggest number that you can come up with? What's the smallest number that you can make, right? So they're just flipping around the 2 digits. Roll 3 dice, 3 different colors. What's the largest number? What's the smallest number? What's a number that's in between your largest and smallest number, right? In grade 3, they have to be able to get from 0 to 100,000 and put numbers on a number line. They don't have to add, they don't have to skip count to it. They just have to be able to, can I place 7,654 on a number line that's someplace between 0 and 100,000, right? Or even 10,000. So just doing those kinds of slower but easy levels gets everybody into it. They feel some success, but it also feeds you the information about what they know and what they don't know. I could take 2 dies and multiply them, right? Do they know that? Best they can do would be 6 times 6. So there's a good starting point. If everybody's acing when I roll 2 dies and they all can call out what the answer is, hey, we know we're ready to go to 10 by 10. If we're struggling there, well, then that's kind of an indicator for me. I need to do some work in that area, and work not necessarily in memorization work, but strategies to figure out how do I get 3 times 4 if I don't know what it is. Show me a way to figure out 3 times 4, right? So subitizing cards that we talked about is one of our tools in the opening one. Those would be great ways to do it too. You can use die, you can use 2 subitizing cards, turn them over and multiply them, right? Fun. Those are fun for the kids. They're a game, but they don't realize that they're doing the math at the same time. So those are those kinds of engaging things that we want them to do. If they're just learning the money, like really just learning, maybe you limit what you give me. I have a whole pail full of just pennies, nickels, dimes, and quarters. I reach in, I take a handful out, I put it on top of my card like this. I sort them based on what the name of the coin is. And then can I make any conversions? Can I take 5 pennies and trade them for a nickel? Do I have enough nickels to trade for a dime, etc.? Starting small, easy, right? And then once they know that, let's add loonies in, let's add toonies in. So there's a mat for every possible trading combination already created. You don't have to make them. Here's one that has the bills on it. Bills are easier, but still need a little bit of practice. 5 loonies for a $5 bill, 2 $5 bills for a 10, and so on, right? So again, I just reach in, I get random packs given to me. What's in my bag? Is there anything I can trade, etc.? We did create a template that has 6 $1,000 bills on it. They match the size of your $100 bills. So because they don't make them anymore, we needed something that would be just a little bit larger numbers for you to work with. So those are included in the resources that I'll share with you. So you just have to photocopy them and cut them up. So if I were to look at this one here, this is what we call the base 10 mat. And if you watch it carefully, what I'm doing here is really your base 10 blocks. Here's my unit, here's my rods. I'm not telling them that, and I don't even want to see base 10 blocks until I'm proficient at money. Because if I'm a student who asks the question, I got that asked to me grade 8 years ago, where the student said, why do I even care about trading these plastic little squares for these rods? Like, who cares? And you know what? That's a really good question. Because they don't see those in the world. They don't go out and buy something with a rod. But if I have a dime or if I have a $10 bill, that I buy something with. So to give me a real world context about why I trade and convert things is real in their minds. It's not real in a base 10 world. But that's not saying we're not going to use base 10 blocks. We are. We're just not going to use them right up front. Just stay with money. Be intentional, just resist the urge to bring them out and just work with this. And so here's our base 10 pennies to a dime, 10 dimes to a loonie. So really what's sitting here is that decimal. I don't have to go there right off the bat, but really they already know these are cents, these are dollars. So I'm dealing with dollars and cents. So they start to say that on their own. Well, these are the cent sides. Okay, so how could I separate the cents from the dollars? Well, we could use that little black dot, right? The decimal. Some of the kids don't know what that was, even in grade 6. They did not know why the decimal was there. So then we wonder why kids don't know how to line up and the reason that they should line up a decimal. But if I'm dealing with dollars and cents, and I know that cents go with cents, that lineup is obvious because I don't put the dollar over in the cent side. Doesn't work that way. So that's where learning money as the tool becomes a really important piece. So here's kind of those 2 bags that I referred to. These are in the grade 3s, and you could use that for just general. If I wanted to just build a bag for them to learn, or if you're a K to 6 school, you could probably borrow, if your K3s already have money in their schools, you could just borrow the bags from them. You don't necessarily have to recreate them. If I'm just learning how to show you 54 cents 3 different ways, or I want to show you $1.54 3 different ways, whatever, okay? But if I'm past that and I can do that and I'm good with it, then here's kind of where we want to land in Div 2 and Div 3, is we want to use a base 10 model. So here's just some suggestions about what we put into the bag. And for those who might be ordering money because you don't have it yet, I did approach the company Spectrum and ask them if they would consider, instead of selling us these little bags of mixed stuff, not saying we shouldn't buy those, but we don't need those a lot. What we need is a lot of these. We need a lot of pennies, a lot of dimes, a lot of loonies, etc. So they're creating bags of 1,000 pennies, 1,000 dimes, 1,000 loonies. So they'll just be bulk bags so that we can just take a handful and put them in a bag, and then the kids won't run out. We don't have to limit that to 3 loonies in a bag or something like that. So these are being priced out right now. I do have the numbers to order them, but I don't have prices yet. So when I do, I will let everybody know, or you can just email me if you're ready to order. And if I have it, I can share that with you. So this is kind of what we put into that bag. And then I also cut up about 6 to 7 $1,000 bills and put them in each bag too. So just so that we had lots of easy, show me $254. I didn't run out of $10 bills and loonies and whatever. So I'd start with cents. If your kids come to you and know nothing about money, nothing, like know nothing, start with cents. Just start with 100 cents, 100 pennies, 100 whatever. I can convert later. If I'm going to do adding and subtracting, I'm not going to do cents. I'm just going to do dollars. I won't worry about it. But here I can do this. Eventually, when the kids get down here, they say, well, I'm going to run out in my bag. I don't have a lot to do a 196 cents 3 different ways. So we ask the question of students, is that what you see when you go to the store? And even grade 6 students struggle to say, no, that's not what you see, but they couldn't articulate what they actually see. Some of them still said an S with a line through it. So they didn't know to call it a dollar sign. So this is why I say don't assume they know it. Some kids will, for sure. But you need to really find out in money who knows and who doesn't, and partner the who does know together, and partner those who don't know together. Don't partner them with one who does and doesn't, because the ones who don't will always get overrun by those who do. They're going to just quickly do it. And that doesn't help those kids learn as they go through. So this is one of those intentional times where we partner like abilities deliberately. So I need to know what 100 pennies looks like. You need to ask the students, how do you know there's 100? They might have counted them by 1. Some might have gone, I see that there's 5 and 5 in a row. Some will say I see 10 in a row. Some will say I went 10, 20, 30, 40, 50. Some will say that I see 10 frames in here. I see 20 groups. I see $20 bill. Ask them what they see, because not everybody sees the same thing. The ones that we're listening for are the kids who eventually, every time we give them an array like this, are counting by ones, right? That's an important piece for them to know. So in base 10 blocks, we change the rules on students, right? We say, man, when we get to decimals, we're going to change the rules and say the flat is a 1, the rod is now a 10th, and that little one is going to be called a 100th. We tell them that. But in truth, the kids who got lost to begin with the base 10 blocks are definitely off the rails by now, because you just changed what I just figured out is 100. Now you're calling it a 1. So instead of doing that, if you wheel around that flat and open it to the back side, you will see 100 holes, especially if you have the old ones. It doesn't matter what color it is. But 100 holes is 100 pennies. If I filled each one of these holes with a penny, I built a loonie. If I filled a whole row, I have a dime. So where are we going? We eventually are getting to 1/10 and 100. A penny is 100th, one of the 100 holes. A dime is one of the 10 rows or columns on here. I can see that. I could fill it in. This makes more sense to kids than changing the rules. And now I don't have a limitation as to what numbers I can ask them. I'm not going to run out of blocks like we do in base 10. I can ask them any number I want. So dollars and cents, right? The cents live over here. Dollars, 3 cents, $1.03, $1.26. $1.26 replaces that whole notion of taking this and having this be the one with the flat and then coming over here. Now I'm going to say this is the same as my loonie. And it's these little holes that I'm filling up that are my cents. So I don't have to relearn anything. So I can have $12.51. You'll see the word efficiently. That's a word I use. I'm not saying it's a mathematical requirement, but eventually I don't want to see kids counting out by ones. I'm asking them to be as efficient as possible. And if I'm only allowing them to use coins, what are the least number of coins that you can show me to give me $12.51, right? If they come up with a different configuration, I'd say, good job. You did show me $12.51. Now, is there one that you can be more efficient, right? Just to get them to learn that eventually what we're trying to do is build those tenths and hundreds. I'm not telling you where the dimes are. I'm not telling you where the pennies are. I want you to do that for me. So you're replacing this whole notion of taking a little unit with a penny, with taking the rod and making it a dime, with taking this unit or the flat and making it a loonie. So we're not changing the rules when we use money. Let's look at the second one that you have, and I've already highlighted these, so we won't go through and do the concepts. They're already on here. Students add and subtract. Well, let's just do basic addition, right? Make it simple. Don't make it hard. Make it start at 100. Mastery. You could use dominoes. You want a fun way for them to do it. They think they're total power because they get to choose what the domino, which way it's going to go. I don't really care which way it goes. Make me a 2-digit number with a domino of 6s, and underneath it put another one, and then add the 2 together. And if I get stuck, I could even add the dots. And if I have to regroup, I can do that, right? I can change it so that everybody's in. And if they're good at it, then maybe try 9s. Dominoes come in 9s. If they're good at it, try dominoes that come in 12s. That's a whole different ballgame, right? Because I can put 12 on the left and maybe it's 6 on the right. So now I could have the number 126, or I could have the number 612, right? There's lots of ways I can change this now. So again, dominoes are another way that I can just engage them to find out what they know, take them one step higher, give them a few challenges as we go. I can use money to do the same thing. I can use the money just to start off with to practice my 12 by 12. So use your 100 pennies. What math facts do they see? Could anybody show me 3 by 2? Where would you find 3 by 2 in that array? So if you laminate those 100 pennies, and then they can just use dry erase markers, and they can draw it anywhere in there as long as it's a 3 by 2 or a 2 by 3 that gives you 6. Great. And then you can ask them, does 3 times 2 equal the same as 2 times 3? Show it to me. Box them, right? Give me that value. So I can use money for the arrays and to do that work. So what we're trying to do is replace these base 10 blocks initially up front with money. Hold off, we'll bring them out. We just won't bring them out right at the beginning. If I'm looking at the geometry pieces, it talks about students investigate symmetry as a geometric property. So symmetry as a geometric property, first of all, let's even see if they remember what symmetry is. So maybe take a grid paper and just give them choice. Go grab a pattern block out of the box, any pattern block, I don't care which one they grab, and trace it onto the grid paper. And then if they drew a vertical line right beside it somewhere, and that was your mirror, what would it look like if it was reflected in that mirror? Start small, just review reflections. Okay, that's what I want to see. What if I put my shape on my mirror? Would there be a left side and a right side that looks exactly the same? That's where you're going to get to, is the symmetry. If it was a shape that I could fold in half on a piece of paper, is it symmetrical? Is left side equal right side? Right? But just start with reflections. They've been doing them since grade 2. So do they remember it? And if they don't, there's a good place to start. Take another shape. And when they do another shape, do they remember how to do a translation? Say, wherever your shape is, whatever shape you picked, I want you to move it 4 to the right and 3 down. Do they know how to do that? 4 to the right and 3 down. Do they know how to pick one of the coordinates and move it 4 to the right and 3 down? So that's just getting them to do a translation that they've been doing since grade 2. Make sure they know how to do that. Okay, that's important. And then the last one is a rotation. Don't make it too detailed. Give them something that has some definite curves or corners on it. Vertices. Square is an easy one for my kids who struggle. and just say, once you've got it traced, I want you to take your shape. I want you to pick one corner. I don't care which corner it is. And if they're not sure, tell them bottom right-hand corner if you're going to use a square, and turn it 90 degrees to the right. What does that look like, right? So any shape they can do. But if I'm struggling as a student, I'm going to use a shape that's easy. The square is easy. Okay, that's an easy one for me to work with. So 90 degrees to the right. Where you're going in grade 5 is you're going into rotational symmetry. That comes from the grade 9 curriculum. It's not a difficult concept, but if the kids don't remember that language yet for reflections, rotations, and translations, that's a worthy thing to start with first. Now, if I'm doing this and I'm on a grid paper, once I've practiced reflections, rotations, and translations with you, why wouldn't I start to teach you how to put a coordinate on a coordinate grid? Because at some point, I'm going to take those shapes that we just moved and say, what are the coordinates of your first starting point? What are the coordinates of where you moved it to? So I'm going to take both the geometry and the coordinate geometry, and I'm going to put them together. So I'm going to work on actual grade 5 outcomes right now. So once I've practiced transformations, I'm going to now say, let me show you, let's talk a little bit about what if the number line that went just to the right of 0 went up? What would it look like, right? We're going to build the quadrant 1. And coordinates are easy for kids. The most difficult part is to remember that they have to go X before Y, right? That's the only difference. Some kids go the other way around, but they need to remember it's left, right first, and then up, down, right? So I always say X before Y. So when I'm working through these, I'm going to make sure that I get some practice at the trend. I'm not doing everything that you see in my outcomes, right? Just bits and pieces. So down at the coordinate geometry, I can start showing you what would happen when those two number lines get put together. What kind of a corner do I create? And this is my X line. And now, because I'm used to seeing a number line that starts at 0, what if the number line swiveled on that 0 and it went up? So how am I going to tell the difference between them? So we can call that a Y. We can call that our vertical, right? And our horizontal. So we give them the terminology that goes with it, and then show them how to do a coordinate ordered pair of X, Y. So this is where I do my practice, but then I can get in here and I can start doing a quadrant 1 material with them. So then when I get into here where we're talking about algebra, remember we just said start small, leverage your multiplication facts that you're trying to practice with them, and just do they know addition before or multiplication before addition. Just start small. And if they're a little bit larger, then put a bracket in there. They've already done brackets. It's not new to them. So they can go ahead and put parentheses in. So then just increment them. But you don't have to get through every order of operation all the way through by the end of September. You've got tons of time because we're going to get into expressions and equations. So we give ourselves time to just understand what the processes were. So in here, we also have a set of outcomes that I'm going to share with you. It starts in kindergarten, and I've done them all the way through to grade 6. So on the next slide, you have a link in here. And when you click that on, you will get one of these for every grade. Well, there's several pages for every grade. Anything that's highlighted in yellow tells you what money could be done. Money could be used to beat that outcome. So this is why I'm harping on money as a tool, not just financial literacy, because I need to learn it. And there's so many benefits to using it as my tool that if I can do that, then I'm going to be that much further ahead. So you have access to those. I've also provided you with some videos. Kids are enthralled with money. They love seeing those $100 bills. Man, they just think those are for real because they look so real. But maybe they don't even know a lot about of the different banknotes and whatever. So these are 3 unique videos. I wouldn't show them all in the same day, but it tells you about how our new polymer money is made. This one down here tells you about what could you find on a $100 bill, which most adults don't even know, that there are windows and numbers and words that are hidden on a $100 bill. Where do you look for them? So some interesting little tidbits that you might want to just to give them some interest in the money. So we really want to make sure that they see money in terms of a tool, but also see money in terms of our financial, because in grade 5, they're doing a budget. And I can't do budgets. I can't even have a conversation about what am I budgeting for if I have not got a really sound understanding of money and all the terminology that goes with budgeting. So we talked a little bit about knowing your coins. If the students come to you and they don't know anything about money, maybe enthrall them with one of the videos first. Start small. There is a link down here where you can purchase a teacher paid teacher. And I'm not a big fan of teacher paid teacher, but I am when it comes to saving time. This one is done with every coin, gives you tidbits, gives you information about the coins. And then it gives you a number of different worksheets that you can work through with the students for counting money, adding money. Great way to do double-digit addition is with that as well. For those of you who don't have any resources right now in money, but need maybe even just to have something virtually, I'll grab this link and I'll put it in the chat box if you want to grab it from there. And you could share that with the students. There's nothing secret about this link at all. Okay, it's in the chat box. So when you grab it, go ahead and download it. And when it comes up, it'll come up with a whole bunch of selections. Grab the one that says money, and to the right, it will say open. Just click on the open and then just save it to your computer. And if you have not seen this before, I'm not going to go through the whole thing, but I will show you some interesting and important little buttons to push just to start with, and then you can kind of find your way through the rest. So when you work with this thing, you can drag out whatever you want. It's very authentic looking. I mean, it is great. This is how I make my slide decks and all my work that I do. So this is one place that I can do that. But if I don't want to grab out one at a time, and this is another place for them to show you any dollar amount. If they have their own Chromebook in front of them, you can give them each a different sticky note when you walk by and say, here's the number I want to see. So if I don't want to drag out things one at a time, down here in the bottom right, you have a little arrow that points up. I can increase by 2, 5, or 10. So whatever I have it set at, if I want to show them what $1,000 looks like, if I set it at 10, I can drag out 10 100s and show them what 1,000 looks like. So it's a faster way to if you have to put things on a worksheet or whatever you're wanting them to do, then I can change that up pretty quickly. Okay, so when I do this work here, I also might want to do a screenshot. And if the background is blue, then that's a bit of a pain because it's going to show up on my screen. So down here at the bottom, you have a little colored wheel. If you click that on, this gives you options for whatever colored background you want to have. So when you have a colored background that's white, then I can screenshot away all I want to do. Okay, and then the last piece is there's a coin missing on your display. It is made, it's just we don't see it very often. So again, if you go down to the little cog, the wheel, the settings, click that on and you'll see that there's one that's not check marked off here. That's the 50-cent piece. So just click it on, go back up to the top right and click it off. And now you'll see that you have 50 cents, which is a great 1/2 for $1 conversation, right? There's another unit fraction that lives there. So these are just ways that we can get in there and do some of that work. So when you're working with money, we want kids to be really quick, really proficient, all right? So I can see 10 here. Some kids see, I see 2 5s. I see 5 and 5 is 10. Some will go, I went 2 4 6 8 10. Ask them what they see so that you kind of know where they're coming from. Each row is a nickel. I can trade that for a dime. So it's just quick conversions. Do they see 5 by 5 or what do they see? Some kids will say, I see 2 10s and a 5. Whatever they see, can you convert it? 2 10s and a 5? Sure. Can I convert that again? Sure. 25 cents. So it's just quick, but these are my arrays for multiplication as well. Can you show me a 3 by 2? Can you show me a 4 by 4? Can you show me, what else can you show me? Let them tell you what they can see. How many can they find, right? In that 5 by 5 that they see. Here's your 100. And I'll be honest with you, we learned really quickly. 5 by 5 was a huge mistake. We started with grade 3s on that, and after 3 days, we abandoned it, and we went straight to 100. Because if I'm going to ask you to find certain arrays, and I want to practice with you 10 by 10, and then I want to enlarge it to 12 by 12, I need this kind of a thing to happen. So laminate it, so you don't have to keep running it off, so that students can use it for the different multiplication facts. But this one in particular sets up your unit fractions that we want to practice. So here's my unit fractions. This is 1/20th, or 1 out of 20 possible nickels, right? That's how I'm going to say it with them. 1 out of 20 possible, 1 out of 10 possible. So that's my unit fraction work that I want to get into. This is a format that you have. It's linked in here down at the bottom. When you click on the link, you can download this to your computer, share it with the students. It's a slide deck. Don't go into slideshow. I'm in that right now, but don't go into slideshow, because if you do, then you can't drag the coins. Stay out of slideshow. At the top, you can edit to whatever number you want me to show you in 4 different ways, right? Good formative assessment right there. And if Julia is ready for thousands, I might ask her to show me 1,250. And if Desiree is working at 500, then I might give her a number like 485. And if I've got Jamie who's able to handle 10,000, I can change this to whatever I want. The more that they change them to, you'll see that there are higher bills and stuff that they can use. So it's just a fast way for you to be able to do that. Same thing with this. I can create that slide deck using that app that I just showed you. I can create something where I just do a quick, tell me how much money I have. And what we did is we actually did these, and then we sliced them horizontally into strips and laminated them. So I could just randomly go down the rows and just hand them out. So nobody got the same thing. So easy to do with that app. Here's where I take the numbers and put them on a number line. Put my dimes on a number line. And then this becomes my first out of 10 hops that I'm going to do. Not 1/10, not numerator denominator. This is my first out of 10 hops that I'm going to do. And every hop is exactly the same distance. So when we do this in person, we'll unpack that terminology that goes with it. But that's basically counting by unit fraction. That's what I want students to do. And they would have already done in grade 3, solidified in 4. So we may have to do a little bit of work there. Okay, you could just use a simple number line like this. We put 4 of them on there so that we could do pennies, nickels, dimes, and quarters, whatever you want to start with. But here's a picture of what a student did when they did the nickels. So when we put them all on one, they've done equivalent fractions in grade 4 new curriculum. I don't want to talk about equivalent fractions. I want them to tell me what they're seeing, and then we'll get into the terminology. So if I have them do all this work and then I ask them to put a ruler down 50 cents, because 50 cents is 50 cents. I did it with different coins, but what did I find? Well, I found the kids said the top number was half of the bottom number. They didn't say numerator and denominator because they didn't know it, but they did know that the numbers were exactly half. But when we moved it to the end, they saw the numbers were the same, and they said, oh, well, that makes sense because you got to a whole dollar. Oh, so then some kids went back and said, well, then that makes sense because you only went halfway. So that's maybe why the number on top is only halfway for the bottom. Very few of them made the connection of equivalent fractions. But that's a discussion to have first, right? And what patterns are they seeing? It's a pattern question. I can do the same kind of thing if I said this is a numbered sheet that goes 0 on one side and 1 on the other. How many hops do I make here? I have 1 out of 2 hops. This is my second out of 2 hops. Now, students, fill it in on your own, the rest of them. The link for this is right here. I could do it and show you what the students did. And some of them will say the hops and they write it the way they see it. They'll say, this is my first out of 3 hops. This is my second 1 out of 3 hops. And this is my third out of 3 hops. So they kind of write it this way, which is brilliant because that's where you're going to go when you teach them multiplication and improper fractions. So this is a nice way for them to actually write it without them even knowing where it's going. Okay, if I move the 1, I get into the potential of being able to say, I have improper fractions by counting, hopping by a quarter, hopping by a third. And then I can go down to the one that makes the most sense to me as a student and say, when I have 4 quarters, how much money do I have? I have $1. What happens when you have 5 quarters? I have $1 and 1 quarter. I can show that as 1.25. I can show that as 1 1/4, right? I start to make the connection, but first with money. And it's real. That I can do. After those kinds of things get done, rather than you just saying to me, take the top number, the numerator, divide by the bottom number. How many times does it go in there evenly? Once. Great. How many leftovers? 2. So I have 1 over 1 2/4. All correct. That's just an algorithm though. That's all that is, just a rule. And you taught me the rule. There's ways that we should be able to visualize any number on any number line. So when you're doing the mastery to 100, give them a strip of paper, put 0 at one end, 100 at the other, and say, put 78 on here. No rulers. Where will they put 78? Do they have a strategy to get to that? Change it from 0 to 100. Can they put, 0 to 1,000? Can they put 780 on there, right? Just, do they have strategies to figure that out? And unit fractions would be the strategy. So again, when we do this in person, we will do those strategies and show you how to get them out of that bind so that they have a visual. So even on a test, they could go to the recycle bin and grab a piece of paper and have a strategy to do that. So that's really what we did here, is we just showed students how to find whether it was 500 cents, 500 centimeters, 5,000, 50,000, didn't matter. They had a way to get to that number, even if it wasn't on there. If I give you the number 654, do you know what comes after it and before it, right? Just quick. Give me a number in the 10,000s, give me a number in the 100,000s, give me a number that's beyond, right, into the millions. Like, what do I know for number systems? So the subitizing cards would be a big bonus to have ready to go at the beginning of the year. They're fun. They're fast. I can subitize, call out a number, but I can also multiply. If I turn this over and turn this over, what do I get? Right? So fun way for me to do my math class. In the rotational symmetry, when you're doing that component of it, and I've given you some handouts in the file, what you're looking for in rotational symmetry, other than what we've done in the past, it's like saying, if I had a pin right in the center of this, and I could take the sheet of paper and turn it, how far would I have to turn it before the piece that sits over here fits exactly into its image somewhere else? So in this case, if I turn this thing 90 degrees to the right, it will lock in and fit here. It will lock in and fit here when I turn it another 90. It'll lock in and fit here when I turn it another 90, and it'll turn. So this has rotational symmetry of order 4. So that's what we'll practice doing. And that's what the kids have to be able to do. If they're not good at visualizing, and lots of adults have struggles with that, give them tissue paper where they can actually see it. Better yet, if your school has any overhead sheets from old overhead machines laying around, they're the best, right? Because then they can mark a little corner, and where that corner has to line up with the next corner, I got it. I can just slide that paper around. Easy for them to see. So I've included a couple of them on here. And this is really important for them to understand time. In grade 3, they learned how to do clocks. In grade 4, they finished time. So by the time they get to grade 5, we're masters at time. We're masters at seeing angles with the hands on an analog clock. And that would help me answer the question about what is the order of rotation in this picture and how many degrees am I turning it, right? They know that 360 is once around the clock. They know how to figure out 10-minute increments are 60 degrees, or 36 degrees. So I can start to increment them. If there's only 6 turns, how much am I turning, right? So this is another way to tie that piece into it. Same with this picture. So I've given some of those into your slide deck for you, and you'll have access to those. So once you get to that, and it will be sometime in October where we work on that rotational order of rotation, then you have some pictures that you can use, and anything will work. Use letters of the alphabet. Which letters can you turn over top of one another? Which ones do you have to go all the way around, right? That's the only way that they work. So there's lots of different possibilities, different shapes in your classrooms. What do you have in your room that you could turn more than once and it would still line up with each other? Let them go home and find something from home and bring it to school, right? Just to make it more engaging. Okay, so I'll stop the recording before I ask any questions, because I know that some people don't like to be recorded.